I'm going to give a historical overview of Santa Clara County streams. I just want to thank some of my colleagues and folks who've contributed. There's really many people. The slide was going to get, it's too small font. And I wanted to thank some of the funders for this work, and in particular the Water District, who has been the primary funder for the work that you will see, and really deserves credit for supporting this. And another number of other groups have then joined in and contributed and made this happen. So next slide. Historical ecology is a tool for understanding the modern contemporary landscape and the options it has for the future. It helps to know about how people and nature have shaped the ecosystem we have here. And it gives us some suggestion of what sort of things we might be able to manage in the future towards ecological benefits. In fact, many things that we might have forgotten about because our own personal history on the land is usually relatively short in comparison to the changes that have happened over the past really 100 or 200 years. So we don't necessarily remember what we should restore. So it's a simple question. The answers are not simple, though. And then figuring out what to do with this information is a complex kind of evaluation that many people should be involved in, deciding what makes sense in what places. But we can't have that discussion without developing the understanding of the native or historical landscape. So it's a pleasure to present some of that to you here. So what we do, unlike most science, you guys can hear this, right? Yeah. I sure can. Now, so we develop scientific data as any other scientists do, but we don't get to go directly to the landscape since it's the historical landscape. So we are using historical documents as this intermediary. And then we do field work then to try to confirm and evaluate things that we find of interest. Next slide, please. Oh, there's that. I wondered where that was. So this is the area I'm going to talk about. This is the Google Earth version, which places we all know and love. Northern Santa Clara Valley. San Francisquito Creek comes in over here. Coyote comes in here and comes all the way down here. Here's the reservoir. So this whole area. And then this portion of the county, which drains south into the Pajaro River and down into Monterey Bay. So that's the Google Earth version. And next slide is the earlier Google Earth version. This is a nice postcard from San Jose Public Library that I like a lot. So we're talking about this area, and as well as the extension down here. I love how the route out of the bay at this time is to the Panama Canal by boat. Now, this is sort of an in-progress talk. It's a fun talk because I do have stuff to share with you that we've found out, but we're also sort of partway through. Different pieces of the project. Coyote, we've pretty much finished, as much as you can finish anything. That report is available online. South Santa Clara County, we're pretty far along, and we're bringing the rest of sort of the western side is not quite as far along, but we're pretty much into the thick of it. So some of my examples may draw from these places a little more. Next slide. So a pretty simple talk outline. I'm just going to make, there's many points one can make, but I chose 4 that I think are significant to talk about. The variation in riparian habitat, the idea that one size does not fit all. You had a diverse set of streams down here. They look largely more homogeneous now, but they were more diverse historically. The question of seasonally dry reaches versus perennial reaches. The finding that many streams, arguably most, were more discontinuous channels with wetlands and related habitats integrated within the fluvial system. And then Guadalupe River is kind of a special place. I thought I'd present some real recent findings about that. And then a few implications for discussion. Next slide. So looking at riparian habitat, next slide, we see a lot of this kind of pattern. So this is 1940s or 1939 early aerial photography. This is Coyote Creek near Hellier Park today. And you can see orchards, and this is the channel. And it's a very broad, gravelly, very wide, active scoured channel with bars or terraces on the sides and scattered large trees. And that pattern holds up for much of the length of Coyote. And we might wonder, well, geez, this is 1939. There's been a lot of stuff happening in the valley up until this point. Maybe they cut down the other trees. But it's backed up by earlier sources, such as this survey, which crossed right here and describes large sycamores in the middle of the creek in 1858, and distances to those trees suggesting pretty wide spacing. Anyways, et cetera, et cetera, et cetera. Lots of sources confirm this general pattern that you had more of an open riparian system than we often see today, historically. Here's another 1920s image of Coyote Creek. You can see a broad, gravelly, scoured system. There's a sycamore probably in the background. Sort of scrubby. It's a very active, dynamic system. And what happened to these places, here's that picture again. Next slide is the same spot, Cottonwood Lake there. Yeah, hey, that's what I do there. Yeah, that's fun, huh? You go back and forth a little. I mean, it's almost unrecognizable that this, okay, that's probably good. I always wonder when I drive people crazy, but, and I guess that's about the point. So this is the riparian corridor we know and love, and in fact has been celebrated as the best historical remnant of riparian habitat in the South Bay. And it may be special, but it's not a remnant of the historical landscape. It's a relatively new feature. It's a dense, cottonwood-dominated, riparian, closed canopy riparian forest in the place where we had more sycamore alluvial woodland. So a very different system. And that is largely the result, next slide, most likely, of the regulation of these systems, the installation of dams, which results in, 1936 is when the first substantial dam went in on Coyote. And so before that time, you had most of your flow into January, February, March months. And so those were big, scouring, active floods that scoured out the channel, kept it open, and almost no flow in the summer. And now you have it's spread out. You don't have the peaks in the winter, and you also have flow, in the summer, which can help things grow. Species like cottonwoods, which like a little bit more water, and willows can A, get established, and B, get supported through the summer. So we've caused a real shift in these systems. Interestingly, there's a reach of Coyote up in CoyoteValley. Here's the reservoir. Here's the Narrows. Next slide. That has some of that sycamore alluvial woodland scattered, more open riparian corridor still intact, which was kind of intriguing. Next slide. So, that's looks a little more like it did. And then there's next pair. In this really unvegetated area in Coyote Valley, which is thought to have been a problem area, like, wow, we need to get more trees in here, actually is probably a decent remnant of the historical pattern. Next slide. Which, was much more open, So, interestingly, this is probably because that part of, next slide, that part of of Coyote Creek is actually somewhat protected from the summer flows by the Coyote Creek diversion canal, oddly enough. So it's not getting the same summer flows. So I think that's probably the reason it hasn't transformed as much, ironically enough. So that becomes an area with mature old sycamores that we should probably try to protect and preserve, arguably. Before this information, it had been thought that it needed to be converted to be like the rest of the stream. Instead, it's somewhat of a remnant. And we might look at other places where, if, as a society, as environmentally interested people, we think that habitat is of value, it could probably come back in places, or at least we could try. Here's Ogier Ponds, where some restoration effort probably will go on. This is the historical extent of the channel. These are old sycamores here. This is a former channel. Potentially one could try to activate this channel by notching it, get flows in there, move some sediment around, get some young sycamores going. Anyways, those are the kind of ideas that become possible with this perspective that may be a good value for the stream. Next slide. I'll talk about that a little more later. And so that's Coyote. Here's Yaga Creek, similar pattern, a shallow stream with gravel bars on the sides, sycamores, right down there on those bars. Next slide. Cuevas Creek. This is a hint of the same kind of braided channel pattern. Next slide. And that's in contrast to other stream reaches. Like here's Lower Guadalupe, which was really densely wooded, broad, thick, perennial, lush riparian forest. Next slide. Here's a little zoom in. This is an 1850 map, really detailed. So this is thick, wide riparian forest. I'll explain that a little bit more when I get into the Guadalupe story. So this is an overview. Santa Clara County is a big area to talk about. There's a lot of different streams. So I'm not going to get into every different reach, but just giving the idea, next slide, that there were reaches that were kind of narrow, more perennial, like this Lower Coyote Creek, and had parallel corridors of trees, and there were reaches that were very different. So we want to, we like to get to know those. Next slide. So one of the things that has what kind of caught us by surprise a little, although it probably shouldn't have, given this is a semi-arid region, is how much evidence there has been for, next slide, thanks Monty, how much evidence there has been for streams being summer dry or intermittent, seasonally dry. This is evidence listing different sources of evidence for Coyote Creek, for much of the length of Coyote Creek, which, let me stick with that slide for a sec. And this evidence comes from comments like this by a surveyor in November of 1851. It comes from, this is a challenging question because, of course, every year is different rainfall-wise in California. You want to be sure you're not just looking at a wet year or a dry year or a dry decade or land use effects. But interestingly, this information comes from Spanish times, when the creek was called Arroyo que seca anualmente, which dries annually, from 49ers who crossed the stream, et cetera, et cetera, et cetera, et cetera, before major water changes. So we feel pretty strong about that. And next slide. Many other streams show this phenomenon. Here's Guadalupe River upstream of about Willow Glen, Arroyo Seco de San Jose de Guadalupe. It was called the Arroyo, the dry creek of the city of Guadalupe. So this pattern is observed again and again and again. Excuse me. Next slide. Similarly for Los Gatos Creek, just some samples. Dry except in short time in rainy season. So the perennial reaches are actually quite special when we do find those. Next topic. So I'll give you a lot of information here. Hope to have a little time we can discuss it at the end. But just to introduce these topics, discontinuous streams integrated with wetlands. Next slide. This is another pattern, very common throughout the South Bay, and not something that we were looking for when we started our research. Here's Stevens Creek. This is heading north, old El Camino Real. You can see it has a defined narrow channel here, and then it just sort of starts to spread out and fizzle out, sort of spreads out in this oak grove. and that is repeated by many other sources, and again on many other systems. Next slide. Here's a USGS map. Around 1898, it was surveyed, and it is a little faint, but if you can see these creeks coming out, this is East San Jose. These are streams like Thompson Creek and Silver Creek. They are coming out of the hills, and then you have this little crowfoot. See that there, and there, and there, and there, and there, and there. None of these streams, all of them are fizzling out on the coarse alluvial fans. So they don't have enough power to maintain channels, and they're fairly naturally erosive systems. They have a lot of sediment. So they're just filling themselves up, and then they still have value. They're spreading their water out into wetlands. Like this is a big freshwater marsh. Often those then overflow into channels which then, or swales which connect down into the original system, but it's not a well-defined channel. Now, people often throw bricks at this point in the talk, thinking that that means none of these streams had steelhead. But it doesn't necessarily mean that. It does complicate the story a little bit, but steelhead can often get through these kinds of systems. You know, it's not necessarily a bad thing. It's even potentially a good thing. You have something like this, Campbell's Creek. Here's a great map, 1850 railroad survey. So it's trying to deal with drainage along the railroad. Here's Guadalupe, Los Gatos, Campbell's Creek, Saratoga. And you can see the pattern. It's coming down here, spreads out into a wetland, and then kind of an independent system starts down here. It's called a sand zone, which literally means sort of a ditch, but often means a channel. It's not really like a whole creek channel, but like that starts from a spring on the alluvial plain and just is maybe more of a slough. So steelhead could probably get up here through this in a wet time and up here. Also, there's some food resources in here, by the way. So you can see between San Francisquito Creek, which clearly connected in, and Guadalupe, none of these streams in the middle had continuous connections across the whole alluvial plain. So that's one of the big changes we've made to our systems. And the change was made mostly before 1900, so nobody really remembers that. Next slide. Oh, here's a zoom in on that spot. One of the neat things, Santa Clara was placed in a really smart place. It's a little bit of higher ground that sticks out here, probably a former route of Guadalupe or Saratoga. And it's sort of surrounded by these wet lowlands up slightly higher. So it was a good spot. It took them 3 tries to get that spot. Remember that? They got flooded out in the first 2. So people learn. So this is an early soil survey, 1903, one of the first soil surveys in the country. And this big adobe area, this big brown blob between the baylands and the more fans, the slightly steeper, coarser ground, is a big clay sort of seasonal wetland area that really was mostly undrained. It didn't have a lot of channels running through it. So we've created a whole drainage network to drain those sorts of things, Sunnyvale East, Sunnyvale West channel, the lower reaches of many of our streams. Next slide. Here's this Yaga Creek coming down towards the Pajaro River. Yagas has a classic, what we picture a stream should do, nice little meandering channel, and then boom, it just spreads out into a willow and tule swamp. This is a nice picture because it also shows there's some ponds in here. There's a lake right down here. And then you get the Pajaro River right here. And we think the Pajaro is probably perennial because it's got all this groundwater coming out here into these wetlands and supporting the river. But up here you have a seasonal system and you have all these wetlands. So you have huge contrasts. In some ways what we do largely is homogenize landscapes. We homogenize creeks and rivers, and we've taken away the wettest places. We've made a lot of the dry creeks wetter, and we made a lot of the wet places drier. So we've lost some of that diversity. Next slide. Here's another example down here where we had Laguna Seca in Coyote Valley. Oh, by the way, these are the maps we make based on hundreds of different sources of information. And this is done for eastern part of the county and will soon be done for the whole of Santa Clara County, the valley portions thereof. So these are oak savannas, seasonal wetlands, freshwater marshes, lots of different interesting habitats. I'm really focusing just on the creeks and wetlands today. Next slide. So you zoom in there, and you can see Fisher Creek just spilled out right here into this, a wet meadow or seasonal wetland. A few other small creeks did as well. And then that became a tule marsh, a perennial freshwater wetland. And then even there were some really wet spots in there that were really ponds. And then on the edge you had willow groves. So a real mosaic of wetland habitats. That's is going to support a wide range of species, from willow-associated birds to potentially floodplain-associated fish. They can get from here to there, as well as, some of these were called duck ponds or mallard ponds. So a lot of red-legged frog, tiger salamander potentially, blackbird. Next slide. Oh, here's a picture of it. It's a rare one we get a picture of. So this is looking at it from Santa Teresa Boulevard, goes through here, looking south into Coyote Valley. Here's those ponds I mentioned. And so these are tall tules, 10 to 12 feet high. Next slide. Here's a picture. Oh, can you go back one? Just so this is a picture. We found these at the Water District Archives. They're really great. So this next picture is taken from here, looking this way. These guys were really detailed and careful about their documenting, the draining of this wetland. And so then they took this picture. You can see this is open water. That's a lot of water. That's a big habitat. And these are tall tules. This is probably its last day, this wetland in 1916, because here's the dredger coming from Coyote up to the pond to drain it. Yeah, next slide. So Guadalupe River, pretty unique, the center point of really Santa Clara Valley and San Jose culture. And I don't have as pretty finished slides yet for this area, but it's really interesting. Some of this has been known, but I don't think all of this had been understood. Guadalupe River really is the combination of two separate systems. One was that Arroyo Seco that I showed you a picture of earlier, which was a sycamore alluvial woodland braided, seasonally dry channel coming out of the hills, and it spilled out over here. So this is Willow Glen, and this is Willow Street. Here's 87. Almaden comes here. Almaden Expressway is over here, if that makes sense, in this Google Earth view looking roughly north. So that's this creek. It sort of came out and spilled out over here into a huge sycamore grove. And then next to it, probably charged by water, in part coming from that creek spilling out into this coarse sediment over here, was a huge freshwater marsh in Willow Grove. And that's where the Rio de Guadalupe started. Nobody considered this part south of Willow Glen to be Guadalupe River. It was a separate creek. And Rio de Guadalupe started here in these springs. And it's really central to the founding of San Jose as a city, because these are some of the springs that supplied water to the city right over here. And it's probably the groundwater coming up right here makes Guadalupe this perennial, reliable, lush, really river, Rio. It's a rare Rio in the Bay Area. Everything else is an arroyo. And that probably is why that's able to be a center place for culture developing right there. And then so those two systems, sorry, I forgot to make the point, were connected by this ditch called Lewis Canal. So that connects this stream going this way with Guadalupe River, which went up here. So that segment is gone, been replaced by this. The two systems have been connected. Next slide. Oh, the other way. So here's one of many pieces of evidence about this. This is a great map from the county surveyor's office. They've been really generous with us. Great sources of information there. So here it is, Guadalupe River coming up like this into that River Oaks High School or River Oaks Park area that I showed you. It says Willow Grove at the head of Guadalupe. And then these are springs in through here. And then here's the Sycamore Grove, Willow Groves, and here's that creek coming over this way. This is still Almaden right here. So this has been interesting for folks who are looking at the restoration plans on Guadalupe River to think that this might help explain some of the challenges they're having. It's with this clay layer in this area, and that willows could make sense. There might even be some groundwater emergence that could be found. So I guess I sort of went through that slide pretty well. So yeah, that's what's underneath that. And so the upshot being that Guadalupe River really is from here to here, from Willow Glen downstream. And then up here is really these seasonal creeks. So two different systems in a way. And this is really the naturally perennial reach of Guadalupe River. Next slide. A few implications to consider. Thinking about the long-term sustainable distribution of perennial stream habitat. At times I think there's the assumption that we should try to make all of our streams perennial, and that would be the best, highest use of all streams. And yet a lot of species and even fish are associated with streams that went dry or had just went into pools in the summer. And in much of our local systems were like that. So and these streams probably have some ecological values associated therewith. So and also they're probably more adapted to the natural climatic challenges that we have. So as we think about the future, when we expect that water is going to be shorter and more scarce, we expect droughts. It raises the question of how effective it's going to be to try to force streams to be perennial. How much of that makes sense? And one of the things that jumps out at me is that as water becomes scarce and it becomes debatable whether these streams really make sense to force them as perennial, we want to identify the naturally perennial reaches, and there are many of those. And those are going to be the places that are kind of naturally have the tendency to gain emergent groundwater and or be at the mouths of canyons that are going to tend to stay wet. They're also going to be near reservoirs. So I think we probably want to be really strategic about understanding those spots as the places that are given natural, are going to be most sustainable naturally, and then figure out how we use our water most wisely in that context. Next slide. So if you look at this is a diagram about Coyote Creek. Here's its length from the canyon mouth, Anderson Reservoir, across the valley to the Baylands. If we look at the historical hydrology, we say, well, it was perennial for the lowest few miles where it intercepted groundwater, and groundwater has come back quite high. So that happens once again. And the first few miles of the valley floor where water's coming out of these bedrock canyons and keeps it perennial for a number of miles before it sort of sinks in. So those are some of the natural spots. And then you have this long stretch that is intermittent, but maybe with some valuable pools. And many of the streams exhibit that kind of character, that kind of pattern. And so where you have these dry middle reaches or lower reaches, and then you have these wet areas at the end. So anyway, something to consider as we think about stream augmentation, reservoir management, aiming for the best places to preserve salmonids, etc. Next slide. Sycamore alluvial woodland. So this hasn't really been on the radar screen for restoration in Santa Clara County that much, especially the northern parts. And yet it's a rare riparian habitat in the state. Only 17 significant sites in the whole state. And two of those are on Coyote. So that should really be valued. And if we want to maintain this habitat, and I'll tell you, this is a different look for streams than maybe what we often have in mind. Arguably, it's an attractive aesthetic, but it's a different aesthetic than kind of the closed canopy, nice corridor. But it might be considered whether this has some value for local streams. It certainly was one of the major pieces of the ecological mosaic of our region. Now, there are challenges, of course, with incised streams and streams that are regulated, so we would have to work hard to bring these places back, but there are remnants, as I showed you. Next slide. And I like this quote from the 1850s because it celebrates this kind of system, which we don't seem to have sort of that inherent appreciation for right now. It's a different look. Like I said, instead of a line of trees, it's these scattered individual large trees that kind of stand out. But they had their own appealing kind of aesthetic where you saw them sort of silhouetted like this picture. Anyways, trying to get to know our native landscape. Next slide. And you had birds associated with these places. These are eggs in the channel. They need scoured channels. Next slide of the lesser nighthawk. So, a whole ecology, of course, associated with this. Next slide. So we could consider that sycamore alluvial woodland has declined greatly in our region, and the current trajectory would be that basically there'd be probably little or none left, in 30, 40, 50 years. So it's our decision whether we try to manage and preserve what we have or even expand it a little bit. It's unlikely that we're going to try to get rid of this stuff, because this is good stuff too, but what's the appropriate balance? And what makes sense given water supplies and ecological diversity. Next slide. Wetland floodplain habitats is part of the creek system. Usually there's people into wetlands, there's people into creeks. These are really part of the same system that naturally managed and distributed how water flowed through the watershed, where it percolated, where it paused and made wetland habitats, where it flowed rapidly through channels. And I would argue, obviously, wetlands, you think, wow, there's no potential for that. But it's surprising. There are some places, there are some things we could do. So I think there is some unrecognized potential. And these places can have multiple benefits for a range of species, endangered species, floodplain fishes, and then natural flood protection capacity. Next slide. Here's one spot. I showed you this slide earlier of Laguna Seca in Coyote Valley. Here it is today, or a few months ago. Still has cracked ground, the clay soils, seasonally wet, despite massive efforts to drain the thing. It never really was good for agriculture, despite everything. It's basically a bowl. So the water district is actually based, largely as a result of these findings, and this potential has moved to acquire that piece of land, and will be restoring, probably much of this system in this spot. So that will have flood prevention benefits as well. So these things are not necessarily as far away as we might think. In this spot, it's really poised to return. Next slide. Similarly, here on the Yaga Creek, I showed you this willow grove. Next slide. And okay, here's the outline on a modern aerial photograph. Okay, it's gone. It's toast, right? There's a lot of farms. This is a sewage treatment plant. Interestingly, look at this spot right here. For some reason, I haven't actually figured out quite why yet, they let this lagoon go at the sewage treatment pond, and it has reverted to a willow swamp just on its own accord. So this is not even any restoration project, and the willow grove is coming back. Groundwater is still near the surface. Willows want to happen. You got willows filling in the channel, right in the filling in the flood control channel and creating a bit of a challenge for flood conveyance. And a lot of the habitat could potentially be restored in the vicinity in these areas that actually still have some flooding potential or flooding problems. So again, native landscape is not necessarily as far away as it seems. Sometimes it seems like we're just sort of barely holding it back. Next slide. Here's another example, Cuevas Creek, which really, Cuevas Creek in San Jose, Blossom Valley, not far from here. It really was more of a slough. It was really wide, had all these ponds, all this marsh around it. Here's the San Bautista Hills. Next slide. So that's been completely channelized, has really no resemblance. But interestingly, it runs through right here. Here's those hills that it curved around, and then it came through like this. Here's the engineered channel. This is a new county park, Marshall Cottle Park. I don't know how many of you know about it. It's pretty amazing. A generous farmer donated it, basically, or sold it for $3 million. It's worth $300 million. And it's going to be a new park. It's 300 acres. It's huge on the valley floor. This area is still low and clay soils. So there's the potential. Obviously, there are a lot of planning issues to go through, but there's certainly the potential that wetlands could be restored in this area. And believe it or not, one of the ponds that we see in the 1850s maps is still visible. I think it's right here. So interesting layers that are still visible. Next slide. So freshwater wetlands. Again, we could assume that there's nothing that we can do, and the current trajectory would be basically there's very little or none, or there are things that could be restored. And I feel like in the Santa Clara Valley, Santa Clara County, despite substantial urbanization, a significant portion of the historical landscape could be brought back, significant elements that would make things, make a significant difference for the ecology of the area. Next slide. My last point, a somewhat complex one, is the drainage network and how it's changed. I sort of hinted at this. And some of the issues around this big shift. like aggradation, riparian challenges, percolation. So next slide. So here's Coyote. So we say all these streams sort of spread out, fizzled out. Here's where that wetland was in East San Jose. And, some of that flow might have made it to the main stem, but most of it didn't because there was a natural levee alongside it. That's why Penitentiary Creek had to curve and just parallel it. So you had, largely disconnected systems, call that, which had the capacity to store water, distribute fine sediment, a lot of different processes than today. Next slide. And you could do that back and forth thing a couple times just to make the point. So we've extended these systems with a drainage network, an artificial drainage network, to make everything connected up. And we did this so long ago, for the most part, really in the agricultural period, that we consider these just parts of our streams. And yet we really have two different types of streams. We got our natural ones, and then we got almost as much artificial in some places. So next slide. Some of the issues, you wonder, well, what are those reaches like? Well, a lot of them don't have riparian corridors on them, but this one's interesting. Upper Penn, here's a straight line extended to connect it to Coyote. Very little riparian forest along it at that time in 1939. Next slide. But since then, it has just of its own accord developed a pretty nice, mostly native riparian forest. So that suggests that these systems can kind of naturalize, at least in some places, and and gain some ecological function, some aesthetic value. But that hasn't happened on most systems, and I'm maybe interested in looking a little more closely why that hasn't happened, like whether trees did start to come onto these systems, but then they were lost when they were converted to concrete channels and the like. Next slide. Another side effect of this very effective conveyance of water out of the valleys into the bay, which of course was the goal of flood control, is that you're moving water very quickly through all this pink area, which is the groundwater recharge area. So that's kind of a bummer. These are all places where the water would naturally recharge our groundwater, which is our drinking water. So it suggests, gosh, we might want to try to find ways to distribute groundwater replenishment throughout these areas. And that can even be done at the neighborhood scale, as people, through the design of yards and swales and, urban areas. That's kind of a coming field. Next slide. And I think my final point, as you might expect, these streams were not competent. As I said, they didn't have the power to move sediment through the really low portions of the valley where it gets really flat. So they just piled up and they became, it spread out onto the valley floor. Sure enough, we have sediment removal problems in those areas. And this is from the Water District data, the amount of sediment removed from these channels. And you can see the largest amounts of sediment removal are usually in these artificial channels. And, it's very expensive, hundreds of thousands of dollars a year. Now, interestingly, next slide. This has been happening for a long time. Here's Stevens Creek, used to end right about here. This straight line ditch was dug like in the 1870s. This is an 1898 map. Next slide. And it very quickly started filling up with gravel and willows. And the surveyor commented on that in the associated notes. And it starts building out a little delta here. You can see that sediment's moving through here. So it's already becoming a problem area. Next slide. But interestingly, and this is a potential solution, these creeks were used to move sediment into the baylands to artificially sort of reclaim the marsh and raise the elevation. Next slide. So you had these farm reclamation areas. This is a whole local history that I think sort of faded away. But it's really relevant to us now as we struggle to find sediment to build up our marshes in salt pond restoration, as well as for flood protection and protection against rising seas. The creeks were used as little sediment hoses to get sediment onto the baylands. In this case, they wanted to raise it up above the tides for farming. But in our case, we just want to keep up with the tides. So, but it suggests that that's the next slide. Okay, here's a little discussion of that. San Francisquito Creek, we're making levees around a certain portion, allowing the floodwaters to spread dirt over and drop the sediment in the desired place. Interesting model. Next slide. And so we have this really jerry-rigged drainage. It's not really showing up on this map. I should have got Christopher's map, the Oakland Museum map here, which really probably doesn't serve us that well. It's a very bizarre, you have a lot of parallel drainage systems going this way and that probably don't serve as well as they could to effectively move sediment into the places where we need it the most. So connecting the creeks and wetlands once again. Okay, next slide. So in summary, we've covered a lot of different material, different topics. This is just sort of an introduction. We can discuss these things further. But you can see how this helps us understand the trends that may not be so obvious because they're gradual, and gives some suggestion of how we might set goals, and then some specific sites with potential, and strategies we might be able to use. And it also helps us understand our contemporary infrastructure, which, of course, always has to be rebuilt and redesigned. Next slide. So this information is largely available. Well, some of it, as you know, we haven't finished all our reports, but the Coyote is online. We have a published journal article on Coyote and landscape ecology that's also on our website. Basically, there's a ton of stuff on our website about the South Bay and Santa Clara County, maps, several different reports, TV segments, et cetera, et cetera. So if you have information, feel free to check those places or contact me. Next slide. So thanks very much.